Hi students, now in this lecture we will discuss about a chemical reaction. What a chemical reaction is. A chemical reaction is a change that produces a new substance from a starting material. So if you get a new compound, a new substance from a starting material, that process is a chemical reaction. Suppose we have a candle burning, right? Rusting of iron. These are the processes which are irreversible. You can't reverse it, right? Normally. So a chemical reaction is a process in which a new substance is formed. In the rusting of iron, from iron you get the ferric oxide, which is a new compound. A candle which is formed of wax reacts with the atmospheric oxygen and forms the carbon dioxide and the water molecules with the release of energy. So this is again a chemical reaction. Explosions and the fireworks that we do, again these are chemical reactions. In the living cells, respiration is going on. Due to respiration, the glucose molecule breaks down into the carbon dioxide and water molecules. Photosynthesis in the green plants, right? So photosynthesis is reverse of the respiration. In respiration, the glucose molecule breaks down into carbon dioxide and the water molecules. In photosynthesis, the glucose is being formed from carbon dioxide and the water molecules. So all these are the chemical reactions. Why? Because in these processes we get a new substance. During photosynthesis, carbon dioxide and the water react and form the glucose. The glucose is a different substance. We can convert ice into liquid, but is it a chemical process? Is it a chemical reaction? No, it's not. By heating, we can convert ice into water, but it's not a chemical reaction. Why? Because here the composition is same. It is H2O. This is also H2O. We don't get a new substance. This is simply a physical change, not a chemical change. In a chemical change, new substance is formed. In a physical change, no new substance is formed. You can reverse this process. You can convert the liquid water into the ice, into the solid, by decreasing the temperature. Let's take one more example here. If you mix the sulfur with the iron, right? This is actually the sulfur, right? And if you mix it with the iron, you get a mixture. See, this is a mixture. Okay? This is not a new compound. This is not a chemical reaction. So no chemical reaction occurs between the sulfur and the iron just by simply mixing. You can separate the two components. Suppose if you take this reaction mixture in a solvent, suppose I take here the methyl benzene, right, the solvent. If I put this whole mixture in the methyl benzene as a solvent, sulfur will dissolve in it, right? Sulfur will dissolve in it and the iron is actually insoluble and iron particles will remain there, and then after that you can just filtrate. After filtering, right, you can separate the two. So by filtration, right, by simple filtration now you can separate the iron and sulfur. So that means once you mix the iron and the sulfur, you don't get a new compound, you get a mixture. So this is not a chemical reaction. However, if I take a very hot metal piece, right, a very hot metal piece, I insert in it, in this one. So basically I am trying to give energy to the reaction mixture, to this mixture of iron and the sulfur. Now what will happen? After some time you will see the reaction mixture starts glowing and a new substance will be formed. A black substance will be formed, right? Once you heat this reaction mixture, you can insert a hot metal rod in it, in the whole reaction mixture, and after some time you will see the reaction mixture glows, right? It starts glowing, and after waiting for some time, for a few minutes here, you will find a black substance is being formed. What is this black substance? It is the ferrous sulfide, FeS. Ferrous sulfide is a different compound. Now you can't separate this by simply with dissolving the methyl benzene. Why? Because now the chemical reaction occurs between the sulfur and the iron and forming the ferrous sulfide. Ferrous sulfide is a different compound. So this is the chemical reaction, right? Once you heat it, it produces a black substance of a ferrous sulfide. So this is a chemical reaction. So in a chemical reaction, new substances are being formed. And now if you take this whole substance, ferrous sulfide and the methyl benzene, you can't separate the iron from the sulfur. Why? Because ferrous sulfide is a new compound. So in any chemical reaction, new substances are being formed. Let's take one more example here. If I react the hydrogen with the oxygen, what I get is water, H2O. Okay, we get water. Now this is a chemical reaction. Why? Because water is a different substance than hydrogen and the oxygen. So this is a chemical reaction. So that means in a chemical reaction, new substances are being formed. And when a chemical reaction occurs, we write down here from the left side, we write down the reactants, and to the right side of it, we write down the products. Reactants get converted into products during a chemical reaction. And when a chemical reaction occurs, bond breaking in the reactants takes place and new bonds are being formed in the products, right? So like in this example, hydrogen molecule, there is the hydrogen-hydrogen bond and there is the O2 molecule, right? So when in a chemical reaction, what actually happens here, the hydrogen molecule breaks down, the bond breaks here. And bond breaking is endothermic, absorbs energy. You require energy to break the bond. You require energy to break the bond here. Okay? And then after that, hydrogen atom forms a bond with the oxygen. Okay? Oxygen has a valency of 2, so therefore 2 hydrogen atoms will react with the 1 water molecule. Okay? Which means that during a chemical reaction, bond breaking takes place in the reactants, which means that bond breaking occurs in the reactants and bond formation takes place in the products. The net energy change is called as the energy of the reaction or the enthalpy of a reaction. Some of the reactions occur with the absorption of energy and some of the reactions occur with the release of energy. That actually depends on how much energy is used to break the bond here in the reactants and how much energy is released when the bond formation takes place, because bond breaking is endothermic step and bond formation is exothermic step. Energy of the reaction depends on the net reaction, the net energy change. How much energy has been used to break the bonds in the reactants and how much energy is released when the products are being formed. That is the net energy change, right? The net energy change, and it can be either positive or it can be negative. If it is positive, we say the process is endothermic. If it is negative, we say the process is exothermic. In an endothermic reaction, energy is absorbed, right? In an exothermic reaction, energy is released. So this is actually the net energy change during a chemical reaction. So we can conclude here that a chemical reaction is a process, is a change in which a new substance is being formed from the starting compounds. And during a chemical reaction, bond breaking takes place in the reactants and bond formation takes place in the product side. Bond breaking is endothermic step and bond formation is exothermic step, right? Hope you got the concept. Thanks for watching the video. Bye for now.